Here we're going to look at solving logarithmic equations using exponentiation. So we just talked about how to solve exponential equations using logarithms. The process is identical, but the main step is opposite. So instead of isolating the exponential part, we're going to isolate the logarithmic part. Then we'll exponentiate both sides instead of taking the logarithm both sides and solve. So here they are already isolated. And then we will raise both sides, not to the 8th power, but 8 to those powers. So this is p equals 8 to the negative second, and 8 to the negative second is the same as 1 over 8 squared, or 1 over 64. Here we raise 4 to each side, so this becomes x equals 4 to the 0th, and 4 to the 0th we know is 1. We're going to raise both we're going to say this is going to be our exponent when we exponentiate with 4 as our base. So v minus 9 equals 4 to the first, v minus 9 equals 4, and v equals 13. Here we have to solve for the logarithm first. We add 8 to both sides. So log of a equals negative 1. Now this doesn't have a base written here, so this is common log, base 10. And then we raise 10 to the negative first equals what's inside. So that is 1/10. I'm going to write that as a decimal this time because I feel like it. Here we have to deal with something outside as well as something inside. So log base 6 of 9x equals 3. We exponentiate with 6 as our base. 6 cubed is 6 times 6 is 36 times another 6 is 216. Divide by 9, and 9 goes into 21 twice, leaving over 3. 9 goes into 36 4 times, so x is 24. So here was a great example of where we had to do something outside. We exponentiated here and on this step, and then we solved normally afterward. We have to divide by negative 4 because that's connected by multiplication. Then we exponentiate. So the input to the log equals the base of the log raised to the other side. Sorry, plus 9 equals 1/8. Subtract 9 from both sides. So 4m equals, what would this be, 72? So negative 71/8. I got a common denominator of 8, so this would be negative 72/8. And then we divide by by 4, and we get negative 71 over 32. As a reminder, these are not connected first. This is not, you do not do negative 5 minus 6. The negative 6 is connected over here to the log there, so you should be adding 5 and then dividing by negative 6. Divide by negative 6. Exponentiate with a base of 12. This is x plus 8 equals 1 over 12 squared, 144. And then this would be x equals negative 8 plus 1 over 144. Just because it's probably easier to write, I'm going to write this as negative 7 and 143 144ths. Lastly, add 9 to both sides. 8 log base 8 of negative 8m minus 2 equals 0. Divide by 8 on both sides. Exponentiate 8 to the 0th is 1. I'll still write it out the long way. It's always better to write it out the long way to make sure that students know what I'm talking about. Add 2 to both sides and divide by -8, giving -3/8. So that is how we solve logarithmic equations using exponentiation.